All right, guys. So here we go. What we're learning about today is the Roman numeral, stock Roman numeral system. Okay. Why do we have to learn this? Well, when we first started talking about elements, we started by talking about the ones that we know what charge they're always going to make. We learned about number one, um, group 1A always forms a plus one charge. Why does it form a plus one charge? Because it has one valence electron, and it's easier for it to lose that valence electron to get to the nearest noble gas than it is for it to um, gain seven more. Does that make sense, everybody? All right, so which ones do we know? Right now, we know every element in group 1A forms a plus one charge. We know that every element in group 2A forms a plus two charge. And then we had our stealth bomber. You guys remember our stealth bomber here? The column that only has one element, silver, forms a plus one charge. Then the next column, we had zinc and cadmium, and each one of those form a plus two charge. So in that stealth bomber line, that's the one that had two elements in it. Then we had one that had three elements, where we had aluminum, gallium, and indium. Okay, if the one column had only one in it, it forms a plus one charge. The column that had two in it formed a plus two charge. What's the charge of the one that has three in it?
Plus three.
These are all going to be plus three. These are the metals that we know what charge they're going to make. These metals have single variance, meaning they only form an ion with that one charge. They never form any other type of ion. Okay? Another term for these would be representative. Okay? What we need to learn now is the next level. We know that if it starts with a metal, it's going to be an ionic compound. But what if it's one of those metals that we don't know what charge it's going to make? So now we need to learn transition metals. And how do we name them? So a transition metal get named using the stock Roman numeral system. Okay? It is still going to be the lowest whole number ratio for that charge, though. Okay? This is important that we understand this. We need to know whatever the charge of the metal in is going to dictate what that lowest whole number ratio is. The problem is we don't know and we can't know which ion that metal has formed until we know what it is connected to. So anytime I'm given a formula, that tells me what it's connected to. So then I can break it down and I can determine what the charge is going to be. And that's what we're going to do today. We're going to break them down, determine what the charge is going to be, so I can show you how to write the name. Okay? Everybody with me so far? I haven't lost anybody. So here's our examples here. We have SNO, SNO2, and SNO3. So what does all that mean? I have, like a covalent compound, I have the ability to have different ratios of elements in a molecule. That's not normal that what we see because it's always been that lowest whole number ratio. There's only one way to do it, right? But if the cation can form different charges, it gives the ability to have multiple variations on that proportion. Okay? So let's look at what we have. We have 110 and one oxygen. Oxygen is in group 6A, so what charge will it make? It makes a -2. I only have 110 to offset that charge. What charge must this 10 have in order to offset that -2 charge? This has to have a +2 charge. So it's a 1-to-1 ratio. I know that this Sn means 10. I'm going to put the charge as a Roman numeral. So this charge goes in as a Roman numeral. And then the oxygen, and what do I write for the oxygen? The anion? Anybody remember? You take the root of it and you change the ending to, so this would be oxide, exactly. Everybody with me? Yes, ma'am. Supposed to be a parenthesis. Oh, you mean over here? It's a +2. All right. So now I have 110, but I have two oxygens. What charge does each oxygen make? They each -2, so a net negative charge is -4. So what's this positive? What's this ion have to be in order to neutralize that? This has to be a +4. So when I write the name, it is 10. How do I write the Roman numeral? Are you guys familiar with your Roman numerals? Okay. Here's the key. 1. You everybody with me on 1? 2. Everybody with me on 2? 3. Everybody with me on 3? And this is where it starts to get a little funky for people because you're never going to see more than 3 I's in a compound like or in a Roman numeral setup. This is why. The next number would be 4, right? 4 is 1 before 5. So 1 before 5 is 4. And if 1 before 5 is IV, then 5 must be V. What's 1 after 5? That's 6. 2 after 5 is 7. 3 after 5 is 8. I see 3 I's. What do you guys think is going to happen now? I'm going to go back to a beginning here. So it's going to be 1 before 10 makes 9, and then 10. We're never going to go more than this. If you guys get these 10 down, you're going to be perfectly fine for chemistry. There's a lot of Roman numerals that I don't know what they mean. I have no idea what Super Bowl we're on anymore. No idea. There's so many weird letters there. I just don't get it. Okay? So let's see. What are we going to put in for this 10? It has a +4 charge. What Roman numeral are we going to put in to indicate a +4? It'd be the IV, exactly. And then what's my NI going to be again? It's the same thing. Nothing's changed here. Everybody with me? So now we have 110 and we have 3 oxygens. What's the charge of each oxygen? Each oxygen has a -2 charge. So Anderson likes to pull this one. What's my net negative charge here? I have -6. So what's the charge of this 10 have to be in order to neutralize all of those oxygens? This has to be a +6. So when I write the name, we write 10. What am I going to write in here? V1, so 1 after 5. And then what's my anion? That's just oxide. Everybody with me so far? All right. Is everybody? There's that one piece. This is the key point here, guys, for the stock Roman numeral. Everybody with me? Ready to write this down somewhere? The Roman numeral represents the charge of the transition metal ion in that specific compound. It does not represent the subscript. Everybody with me on this? Roman numeral represents the charge of the transition metal ion in that specific compound. It does not represent the subscript. Okay, people make that mistake all the time. Happens way more than you know. I have even, over all the years of me teaching, I've even seen teachers do that on occasion. And I'm like, wait a minute, what? You got to know Roman numeral represents the charge, not the subscript. All right, everybody with us? All right, so what I need to do now is let's look at page 13 in your yellow packet. First one, it says, what is the charge of the iron 2 ion? What's that? It's a +2. So number one, we would write iron has a +2 charge. We all there? All right, take a quick check. Thumbs up. Wow, Mr. Cole, this is so easy. I could do this in my sleep. Thumbs sideways. I get it, but we have to do some more problems so I can make sure I get this. Thumbs down. I have a question for you right now, Mr. Cole. Here is my question. Anybody that thumbs down? Nobody has any questions at all so far. You're all cool with this. Yes, ma'am. Outstanding. This is only for transition metals. What she just asked is absolutely perfect. We know what charge group 1A makes. We know what charge group 2A makes. And we know what charge our stealth bombers make. They only form one type of bond, one type of ion. The thing about our transition metals is they're called multiple variants, not single variants. They're called multiple variants, meaning they don't get pigeonholed into only making one type of charge. They can make multiples. Some will make two. Some can make up to 6 or 7 different ones. So you have to look at what it's connected to know what its charge is going to be. Sarah.
Oxygen, since like the last one that we did, tending oxygen ends in oxygen, is that why it ends in I?
Yeah, if it's an element, if the anion is an element, that's a great question, guys. If the anion is an element, it will always be the root of the element with the ending IDE. But there's one exception where something that ends in IDE won't be an element. You guys, that's why I gave it to you on that list on last Tuesday. There's one on that list called cyanide. It is a polyatomic ion, which is CN with a -1 charge. Okay. Do I know why they did that? I know that the original intent was to show that it does not contain oxygen. If you remember our polyatomic ions, anything that ends in ITE or ATE contains oxygen.
So do all elements contain oxygen?
No, you're looking at elements. Elements don't contain anything but the element. These are polyatomic ions. If it ends in ITE or ATE, you should know that it's always going to be a polyatomic ion that contains oxygen. This is a little tricky thing. Do I know why they named it that way? Because it doesn't contain oxygen. But does it really help us with everything else we learned? No. Can I change it? No. The person who made it was smarter and deader than I am right now. So I can't go back and convince that person that we should change the ending to something else. I just don't know how to do it any other way. Okay? That's just one you're going to have to know. Cyanide is the only time you're going to see an anion end in IDE that is not element. Is that cool with that? All right, so let's go to number 2. Number 2 says, what is the charge of chromium 3 ion? Chromium is Cr. What's the charge going to be? Go ahead, John. It's a plus 3. How do we know it's a plus 3? It says Roman numeral 3. If it says Roman numeral, that's the charge of the cation, of the transition metal. And like Regan was asking, is it only for transition metals? We don't have a Roman numeral on anything else other than these transition metals. So it only represents the charge of the transition metal. Period, point blank, no way around it. Everybody cool with that? All right, number 3. What is the charge of the silver ion? We know that one, right? Ag with the plus 1, because that's one of our stealth bombers. Now, when you guys go and talk to your friends, some of the teachers in other classes will only give these. They call it the stairwell. Okay? That's one that even I used to do it back in the day. That would be the ones that I would give. Okay? So if you're working with somebody else, they might have you draw a Roman numeral for these 3. My class doesn't have to because we know what charge they're going to make. They only form a single variance, so we only need to write down the element symbol or the element name. We don't need to put any type of Roman numerals in there. Does that make sense, everybody? All right. So the next one was number 4. Number 4 is asking us, what is the charge of the copper 1 ion? It's what? It is plus 1. How do we know it's plus 1? It was Roman numeral 1. Out freaking standing. You guys cool with this? Y'all with me? Let's do a quick check. Thumbs up. This is so easy. I can't believe that you're taking an entire day to talk about this, Mr. Cole. Thumbs sideways. We should do some more of these so we can make sure we get this before we have to come back. Thumbs down. Here's my question I have for you right now. Any questions? Go ahead.
Will they always be positive?
What do you guys think? Will metals always form positive ions? Yes. Metals always form cations. Okay, before anybody snickers or anything, that's a doggone good question. There are people that are going to make that mistake. They will change it to a negative. So, great question. Way to get that in your head. It's metals always form cations, and cations are what?
Positive.
Positive. Okay, number 5. Number 5 is giving me a name: lithium phosphate. The ending IDE should tell us what? Is that ITE or ATE? It does not. If it ends in IDE and it's not cyanide, that means that's an element. I'm just looking at the element. I'm not looking at a polyatomic. I'm looking at an element. Everybody with me on this? Lithium. It's in group 1A. What's its charge going to be? Plus 1. Phosphide, which is phosphorus. is in group 5A. What's its charge going to be? What's 5 minus 8? -3. All right. So how do I get the formula? I could do it two different ways. I could break it down, or I could do the crisscross. I don't care which one you use. For this one, I'm going to show you written out, though. If I have more negative, then I'm going to add another positive. I still have more negative, I'm going to add another positive. I now have +3 -3. It is equal, and it took me 3 lithiums and 1 phosphorus to get there. That's going to be my formula. Would that have worked with crisscross? Li plus 1, P minus 3. Yes, it would work just fine. Everybody cool with that? Sorry about that. I don't normally look over to my right to see what it said, what's showing there. All right, number 6 tells me I have tin 2 oxide. So I need to come up with a formula for this. Tin is SN, comes from the derivative stannous. What charge does the tin have? Has a +2. How do we know it was +2? Roman numeral indicates the charge of the transition metal. Everybody with me on that? Oxygen is in group 6A. What's its charge going to make? -2. So this is already a 1-to-1 ratio. That's my formula. We're all riding the same roller coaster? All right. Number 7 was strontium nitride. So ends in IDE, is that going to be a polyatomic ion or an element? That comes from an element. Strontium is in group 2A. What charge will it make? +2. Nitrogen. What am I writing out loud? Nitrogen is in group 5A. What charge will it make? -3. So I really don't have a lot of room to just spread it out, so I'm just going to do a crisscross here, okay? I see that 2 and 3 are not divisible by any number other than 1. So I'm just going to crisscross this and end up with SR3 and 2.
So do you not do anything with like the oxygen at the end?
There's
no.
no.
It doesn't give you oxygen.
This one does not have oxygen because it's IDE. All right, number 8. I have iron 3 bromide. So what is my symbol for iron? Is Fe from ferric. Do we know what its charge is going to be? How do we know it's +3, Charlie? Roman numeral tells me the charge of the transition metal. Then we have bromine. Bromine is in group 7A. What's 7 minus 8? -1. Is this balanced? No. So I crisscross it and I end up with FeBr3. Everybody cool with this? I got to pull this up this way. All right, number 9 gives me AlBr3. Do I need a Roman numeral for aluminum?
No.
Why not?
It's not a transition.
It's not transition. We know it's charged, so I'm just going to write aluminum. Aluminum always forms a -3 charge, right? I have 3 bromines. Bromine is in group 7A. 7 minus 8 is -1. So 3 of them ends up with a net charge of -3, right? So that's already balanced. It's perfectly balanced good. So I'm going to take the root of bromine. And what ending am I going to put on it?
Wait, I thought aluminum forms a +3 charge.
It does. But I have 3 bromines. Each has a -1.
I see -3.
What?
I thought you said one's a
No. Bromine has a net negative charge of -3, so it's going to offset that +3 charge of the aluminum. What's the ending am I going to put for this element? IDE. Perfect. We all cooking the same chicken? All right. Number 10, PBO. Kind of got to break that one. Yes, ma'am.
On the last one. Wait, how do you know if it's like I?
If the anion is an element, you take the root of the element and add the ending IDE. Always. Does that make sense? Remember I told you back in covalent compounds that anytime I only have two elements, it's going to end in IDE, unless it's an acid. Yes.
What if it's a cat?
There wouldn't be a cation as the second element because ionic compounds are a cation plus an anion. Make sense? All right, PbO. I have one lead, one oxygen. The Pb comes from the derivative plumbic. So this is going to be lead. So if I have one of each, what charge is the oxygen going to make? In group 6A? -2. What charge does this lead have to have in order to neutralize that? Has to have a +2. So what is the Roman numeral I'm going to put in after lead? I'm just going to put in 2. Why do I know that I needed a Roman numeral for lead? Because it's telling you on here you need it. I want you to be able to see it in your own head, okay? Not just because somebody's telling you. What would you look for to know that I need a Roman numeral for lead? Grace? Not because of oxygen. Regan? What's that? It's a transition metal. It's not group 1A, it's not group 2A, and it's not one of our stealth bombers. I need a Roman numeral because I don't know what charge it's going to make until I look at what it's connected to. Does that make sense, everybody? So this is lead 2, and then oxygen becomes oxide because it's just an element. Anytime my anion is just an element, I take the root of that element with the ending IDE, and that's my anion. Everybody cool with that? All right, number 11 says AgCl. Okay, so Ag and Cl. Do I know the charge of silver?
+1.
It's a +1. How do we know it's a +1? It's in our little staircase or stealth bomber thing, right? Chlorine is in group 7A. This is a -1, so that's all good, right? Do I need a Roman numeral in this name?
No.
Why? It's not transition. We know it's only going to make one charge. So this is just going to be silver chloride. Everybody with me? All right, number 12. SNF2. So I have 110 and 2 fluorines. What charge does fluorine make? They make -1. I have 2 of them, so my net negative charge is -2. What charge does the 10 have to have? This has to have a +2 charge because I have 2 fluorines. All right. So what's a name we're going to write for this?
10 in parentheses, Roman numeral
10, 2, then what else?
2, fluoride.
Make sense? No has any questions at all. All right, let's turn to page 15 and let's do those 3 that I had crossed off before. Yeah, page 15. There were 3 of them that I had crossed off before. Remember these 3? Let's go ahead and get these done together, okay? So the first one is Au2s. So then that means my ions are going to be Au and S. S is going to be a -2 because it's in group 6A. So now I need to find I have to find the charge of the silver here. So I have a -2 charge, but I have 2 silvers to offset it. What's the charge of the silver you're going to need? Plus what?
+2.
Wouldn't I need to have more than 2 sulfurs to make that work though?
They use gold.
Yeah.
Wouldn't it be +2 because you have to like even it out?
I have
Oh, there's
2 of them.
So +1.
These are going to be a +1. Those are my ions. All right. So this is going to be gold. What's my charge going to be?
2.
I have 2 golds.
1.
This is a 1. And then what's it hooked onto? You have come to play today, Charlie. You got your chemistry brain on, and it's in like high gear. I am appreciating this. All right, the next one we had was ZRI. So we have ZR and we have I. It's 1-to-1 ratio, right? The formula only shows one atom of each element in a compound. So, what's the charge of iodine being from group 7A? -1. What's that mean the zirconium's charge has to be? It has to be a +1. So we're going to write zirconium 1 iodide. That's our formula name, our compound name for that. The last one on this sheet we gave you was gold 2 oxide. Make sense? So we have Au and we have O. What charge is the oxygen going to make?
-2.
Excuse me, I'm sorry. I don't know what that just did. Did somebody yawn in here and just cause me to yawn like that? That was a rather significantly good yawn. Sarah's joining me at least.
I'm not yawning.
You're yawning? Oh. You know, they say that when you copy somebody who yawns, that's a sign that you care. So apparently none of y'all care about me at all. Now I know. So that's a -2 charge. I only have 1 gold. What's the charge have to be for that? And what?
Or +1.
+2.
There's 2 golds. Wait, what?
The Roman numeral represents what again?
Oh.
The charge, not the subscript. So it doesn't tell me how many atoms. It just tells me what the charge of the atom is. Everybody with me on this?
Yeah.
All right, so what I need you guys to do is page 14 for your homework. Page 14 from the yellow packet. If you get it done, you don't have to take anything home tonight. So I'd suggest you guys work on it.